So here's some more fun we can have with these first order equations. So here's our integrated rate equation. That's just an equation that tells us how the concentrations vary with time given the rate constant. And, sometimes it's nice, and in fact in lab next week we're going to use this, it's nice to use this as a test. We can say if it's first order, then this equation's obeyed. And if it's second order or third order or zero order or -1 order, this equation's not going to work. So how do we test if something's first order? Using this equation, well, we can go and we can rearrange the left-hand side. So the log of something over something is the log of the first term minus the log of the bottom term. That's equal to minus k times by t. We can go ahead and we can manipulate this by adding the log a sub 0 to both sides. So that's minus kt plus the natural logarithm of the original concentration. Now, here comes the cool part. So this looks just like an equation for y equals mx plus b. And what we're going to do is we're going to plot on the y-axis, we're going to plot the natural logarithm of the concentration. So that's something we can measure. On the x-axis, we can plot the time. And if this equation is right, that is to say, if it's first order, okay, then the slope, that's the value of m, will be minus the rate constant. That's actually a way to figure out the rate constant. And the y-intercept gives us a measure of the original concentration. Oops, don't want to move it too far off screen. And so that would be the log of the original concentration. So we should probably plot that, right? So let's go ahead and plot that graph. So this is the log of the concentration. That's something we can measure. So we plot that typically on the y-axis. Here's the time. This is something that we can't control. It just ticks by. And if this equation is right, then our data is going to look something like this. So we calculate the natural log of the concentration, we plot it versus the time, and we'll get a bunch of points that look like this. And one really cool thing about humans is that we are really good at seeing if things are straight. Lines are straight. So if you've ever played pool and you've held the cue out to look along it, right, you're just checking to see if it's straight. If this is the case, then the slope is minus the rate constant, and this is a test for first order. Now let's say you collect some data, right, and you go ahead and your data looks like this. You plot it out, and you can see pretty easily, right, that it might look straight initially, but it certainly doesn't continue on straight. So what does this mean? This means that if you thought your data was a first order data set, you were wrong. So we don't know what it is. It might be 0, it might be second order, it might be 12th order, but you can certainly say that that cannot possibly be first order decay, whereas you can say that almost certainly is. And on the ACS final, they do expect you to remember that and know what that looks like. We'll do this in lab here in a couple of weeks.